A very good morning to the examiners and my supervisor. I'm LEONG FEI YEE from 4 SCSB Bioinformatics. My supervisor is Puan Havania and my co-supervisor for the project is Dr. Haslina. In this video, I will explain about the work and result that I have done for the PSM1. The field of my project is on system development. The title of my project is Dental Decision Support System for Classifying Malocclusion using Convolutional Neural Network. This is the content that I am going to explain later. There is a total of 6 chapters. In chapter 1, I will start with the introduction of malocclusion. The word malocclusion is derived from the occlusion and the prefix mal is added to define the abnormal condition of teeth relations. In general, malocclusion is used to describe the imperfect positioning of the teeth when jaws are closed. Diagnosis of the malocclusion is done through dental X-ray examination. It's classified into 3 types of conditions, which is stated on the image at the left-hand side. Malocclusion can be fixed by placing braces, but it still depends on the skeletal structure of the patient. DSS stands for Decision Support System. The pyramid shows that a malocclusion classification DSS is the combinations of image-based DSS and machine learning algorithm. DSS is information-based system that aid in decision-making. An image-based DSS is capable to perform image recognition and classification by using a machine learning engine. Deep learning is a subset of machine learning. It has good performance in processing complex biomedical data. The use of multiple layers for features extractions has replaced the traditional method. One of the commonly used deep learning algorithms in image processing is CNN. There are 2 problem statements for the project. First one of the issue of increasing fake dentist cases due to lack of persistency in diagnosis of genie dentists. Fake dentists conduct braces treatment without professional diagnosis that causes braces false placing, which will bring great side effects to the patient, for example, like teeth loss. Second, there are no existing software for malocclusion classification. The currently used method is based on dentist observations, which is difficult in providing supportive data. Regarding these 2 issues, a decision support system for malocclusion classification is proposed as solution. The aim and importance of the project is focusing on develop a decision support system for orthodontists in classifying the type of malocclusion using deep learning. The result is then used as reference by orthodontists before giving treatment to patients. The project has 3 objectives. First is to identify the best convolutional neural network architecture for malocclusion classification using cephalometric X-ray images. Second, to develop a system for analysis of shape of malocclusion and its variation in 2D visualization by using CNN. And the last one, to evaluate the proposed system in the real orthodontist field. While the scope for the project is as follows. First, the dataset used for the project is cephalometric X-ray images, which is obtained from Faculty of Dentistry, Universiti Sains Islam Malaysia. This dataset only involves X-ray images of races of Malay, Chinese, and Indian. Lastly, the system able to analyze the variations of malocclusion using CNN classifier. Next, we continue with Chapter 2. Chapter 2 is the summary of all the research papers that I have reviewed. The summary is distributed into 4 subtopics. First subtopic is about the malocclusion classification method and cephalometric X-ray. Malocclusion has various classification methods that the used by Faculty of Dentistry USI is British Standard Institute inciso method. BSI has 3 main classes, Class 1, Class 2, and Class 3. This method focuses on maxillary and mandibular incisor relationship. Incisor is the forefront teeth for both upper and lower jaws. Class 1 for BSI is near to normal condition, means healthy teeth. Class 2 named as overbite, which the upper incisor is prominent, while Class 3 named as underbite, which the prominent side is in lower incisors. From the diagram, we can see that the Class 2 has 2 divisions. Unfortunately, these divisions are not able to classify using only the 2D X-rays. Therefore, they are not involved in this project. BSI is high dependability since that the posterior teeth did not influence and in conflict with the incisor occlusion. Cephalometric X-ray is the input data for this project. Ceph X-ray is able to indicate the side view of the face. It is used for the study of facial bone and soft tissues landmarks. To identify malocclusion classes, visual examinations and bite impressions is conducted on X-ray. PSS is a computerized program for providing support in determination and judgment of action in an organization. It collects and analyzes data after the produce and information and report that include causes and solution suggestions. There are some existing PSS which is purposely designed for image classification with different types of biomedical images and classification engines. The commonly used engines are neural network, KNN, NB, SVM, and so on. SDLC stands for System Development Life Cycle. It is the project management model that describes the phases involved in driving a project in order to reduce time consumed and assure quality of the system. There are three common methods have been reviewed. The pros and cons have been listed clearly in the table. Waterfall model is linear sequential which stages is clearly defined and easy to understand, but it is poor for complex and object-oriented projects. Agile model is flexible and suitable for changing environment, but it needs rapid customer interaction to keep track user requirements. Iterative model good for problem detection and resolve, but it is time consuming and resources consuming. To decide which model to be used, it is greatly depending on the project characteristics. In this slide, support vector machine, convolutional neural network, and random forest algorithm will be discussed. The table has listed down about the definition, theory, tuning method, and pros and cons of each algorithm. Since three of them are common machine learning algorithms which familiar to us, I will only to focus on the pros and cons of each algorithm. SVM is simple and suitable for large dataset, but its results depends on feature selection done. CNN is good in reduced data preprocessing step since it does not need feature selection. It has also well-known net with great performance, but it is not suitable for unlabeled dataset. RF is good for large dataset and is outperformed with text input data. It is not commonly used in imagery classification. In summary, three of them have their own strengths in different fields, but obviously we can see that the CNN has its strength on combining feature selections and classification in one learning framework. Now we have reached Chapter 3. Chapter 3 is about methodology justification. SDLC model that I have decided for the project is waterfall model. Waterfall model contains mainly 5 phases as shown in the figure. My project is less complex and less specification. It has clear user requirements and the time range is short, so waterfall model is suitable for my project. Technologies used in the system include AI technology, database technology, and lastly website development technology. Software used during this project is varied. For example, like Google Colab used for running code, Microsoft Word is used for documentation, and Draw.io is used for drawing various diagrams. System requirement analysis is distributed into two categories, which is software and hardware. For software, operating system needed are Windows 7 and above. While for the hardware, components involved are input and output devices, 4 GB RAM and above, processor i3 and above, and hard disk. The dataset used for this project is collected from the Faculty of Dentistry, Universiti Sains Islam Malaysia. The dataset consists of 1013 images of cephalometric X-ray. The table shows the proportions and sample size of malocclusion patients, while the diagram shows some of the examples in the dataset. The dataset has imbalanced class, which class 2 is the major class. The diagrams are the example of ceph X-ray from 3 different classes. We are currently at Chapter 4. First part of Chapter 4 focuses on algorithm performance comparison in order to identify the most suitable algorithm for malocclusion classification. SVM, CNN, and RF are the 3 algorithms used in this comparison part. The dataset used is the cephalometric X-ray mentioned just now. Only two steps of data preparation has been done, which is image resize and image augmentation. Accuracy, precision, recall, and F1 score is used for the performance measurement. From the table, we can see that CNN has better performance than the others, but still not the ideal result. Due to the class imbalance and similar features problem, bias like sample bias and recall bias of the model might occur. Further algorithm improvement will be discussed in Chapter 5. Part 2 of Chapter 4 is Requirement Analysis. It contains two components, which is functional and non-functional requirements. Functional requirements are illustrated through diagrams. This diagram is the class diagram of the system. There is a total of 5 classes. 2 of them are superclass, profile, superclass for doctor and student and patient, and user, superclass for doctor and student. Next diagram is the use case diagram. Use case diagram is a representation of a user's interaction between the user and the different use cases. 5 functions are involved in the diagram. Doctor and student are the user of the use case. Some of the functions have included the extent with some sub-functions. Each of the functions are then illustrated using activity and sequence diagram. Diagram A is the sequence diagram for function edit user profile. This is the database or interface involved in these functions, and this is the data flow between database and interface. Diagram B is the swim lanes activity diagram, which is able to show all the possible pathway according to the user options. In the diagram, there are 2 lanes named as system and user and 1 database. Square boxes represent the collections of actions, while the diamond boxes represent the conditions for next actions. The system has 3 non-functional requirements. They are the performance, usability, and compatibility. Performance is the system response time and classification accuracy. Usability is the degree of fitness of the system, which it can tested by usability testing, while compatibility is the measure of the state which the system and its environment exist together without problems. System architecture that used by this project is model view control pattern. The system is structured into 3 logical components that interact with each other. Database acts as model component which handles action done towards system data. User interface acts as a view component which is responsible in displaying information to the user. The view and model components are connected by controller components. This component receives users' interactions and passes to view and model components. Next, we look at this diagram. The diagram is a logical entity relationship diagram. Dentist and student are the user of the system. They are able to manage patient details like register, edit or delete patient data and generate malocclusion result for patients. The data dictionary can be viewed in the PSM report Appendix D. In PSM1, there are 8 basic interfaces are designed. Modifications have done on them when developing the real system. The details of the new interface will be explained in the demo video. In Chapter 5, the development of classification model and wave of improvement will be discussed. The model used for the system is CNN. It's coded using PyTorch and FastAI library. According to the problem that I have mentioned in Chapter 4, which is the bias that caused by the class imbalance, I have tried to solve it by applying the DenseNet 169 and stratified K-fold cross variations with XSplit into the model. Eventually, the training accuracy of the model has improved to 71.1%. Other measurements also increased from less than 0.6 to nearly 0.7. Also, from the confusion metric, we can see that the deeper color occurs in the diagonal. This shows that most of the images are correctly predicted image. However, all the true negative and false positive are related to class 1. The classifier can say to be biased toward class 1. Since there are no existing model yet for this malocclusion classification purpose, therefore, to justify the classifier quality, the classifier's accuracy is used to compare with a baseline accuracy. The baseline accuracy is 45.68%, while the classifier accuracy is 70.1%, which is around 25% higher than the baseline accuracy. Therefore, the classifier performance can consider has to be good quality. Second part of chapter 5 is about system testing. There are three methods used in this system testing phase, which is user acceptance test, black box test, and user satisfaction level test. There are a total of 6 subject matter expertise testers that involved in the testing phase. 3 of them from Universiti Teknologi Mara and 3 of them from Universiti Sains Islam Malaysia. The diagram shows one of the examples of the user acceptance test result. After review all results, this is the summarized feedback, which suggests to add in functions and some wording rephrase. The second test involved is black box test. There are 5 test cases prepared according to the use cases in chapter 4. Each of the test cases is tested with both valid and invalid data to verify the ability of the system to raise error to users and guide them to solve the error. All the test cases for 6 testers can be reviewed in Appendix F. Lastly is the user satisfaction level. The test is done by requesting the user to rate the system performance using 5-point Likert scale, from strongly satisfied to strongly unsatisfied. The diagram at the right-hand side is the Chapter 6 focuses on objective achievement and future work planning. All 3 of the objectives has been successfully achieved along the PSM period. Objective 1 is achieved by doing literature review on several algorithms and running the comparison among themselves, finally come up with a most suitable algorithm for the project. While Objective 2 is achieved when the system has completely built with its decided function. Lastly, Objective 3 is achieved when the system is evaluated by the dentist and orthodontist on its functionalities and performance. In current phase, the system is said to be completed that functionality and user interface completeness. However, there are some insufficient in the malocclusion classification preciseness since its accuracy still has the space for improvement. Refining the training dataset and adding extra features might greatly increase the usability of the system. Besides, the system loading time can also be enhanced to improve the user experience. That's all from me. Thank you.